Our next speaker is an independent consultant helping us with a deep dive into Kubernetes storage. Please join me in welcoming Michael Levan. Michael is a seasoned engineer and consultant in the Kubernetes space who spends his time working with startups and enterprises around the globe on Kubernetes and cloud native projects. Michael, welcome to the show.
How's it going, everybody? And John, thank you so much for having me. Appreciate it.
Yes. What'd you think of our storage lens? I mean, everybody was loving all the information that was coming out.
Yeah, no, it's definitely interesting. I think that the whole FinOps space in general, right? The cost optimization, the resource optimization, I'm seeing it a lot even in the Kubernetes space. There are a lot of tools popping up around cost and resource optimization. I think the whole space in general as a whole is going to become much more relevant, in the next 6 to 12 months. And it's going to be it already is on the top of everybody's minds, but especially for engineers, I think that there's going to be certain specialties, so to speak, or certain avenues that engineers are going to carve out, and that's going to be what they're solely focused on. So those are just my predictions, though. Let's go ahead and wing this. So I'm going to paste a little bit of code into the chat here for everybody. Now, first things first, when you spin up an EKS cluster, it's a little bit different than, for example, I know we're in AWS Fest. Sorry, everybody. Like an AKS cluster. So, for example, with an AKS cluster, when you spin one up, you're going to have default storage classes, right? In AWS, it's going to be a little bit different. You're going to actually have to manually put those in yourself. Now, there are a few different ways that you can do that, but pretty much what you need to do is you need to enable the CSI add-on. The CSI is your container storage interface. Now, this has nothing to do with AWS. This is a Kubernetes thing, right? Kubernetes has several different plugins, container runtime interfaces, container storage interfaces, container network interfaces, all these different plugins, right, to make Kubernetes look how you want it to look. Now, with some managed Kubernetes services, some of them are just on out of the box, while with others, they are not. Right? AWS is one of those. So if you would like to turn that on in your AWS cluster and you're using something like Terraform, you can go ahead and do that with a quick code block. So what you're going to do is, I'm just looking in the chat, you're going to use the AWS _EKS _ add-on, and that's where you can specify your EBS CSI driver. Now, once that's done, what's going to happen is you're going to run a command, and it's going to be kubectl get storage classes or kubectl get sc. Now, once you do that, you're going to see a list of storage classes come up. Now, with AWS, for example, with EKS, you're probably only going to see one, right? If you specify it like I did in the chat with the add-on. If you use something like, again, AKS, I'm gonna flip back and forth just so I can show the similarities. You're going to see Azure Storage Account. You're going to see Azure File Shares. Now, why? Well, because even though CSI is enabled and the plugin is there, you are in a different cloud, right? So one year in Azure, 1 year in AWS. So you're going to have certain storage features that are available inside of AWS. Now, once you do that, you're going to have a few different options. And what it really comes down to is you have your storage classes, you have your persistent volumes, and you have your persistent volume claims. Now, what is all of this, right? Like, what's a volume? Well, a volume is a hard drive. Plain and simple, right? If you want to call it a virtual hard drive, if you want to call it an ephemeral drive, whatever you want to call it, it's just disk space. So when you enable that add-on for, your storage classes and for your container storage interface, and, if I specify again, like in the code, specify the EBS driver, what that's essentially saying is that's saying pull storage for me from EBS. Pull storage for me from Azure Storage Account, pull storage for me from Azure File Shares. It's going to give you the ability to use 10 gigs of storage, 50 gigs of storage, whatever you would like, and it's going to be proposed from that storage class. So you can kind of think of your storage class like, let's say you walk into a Best Buy or you walk into a Micro Center if you have those near you. And you're looking at the wall, right? And there's a whole bunch of hard drives there, right? Whole bunch of storage to choose from. Well, that's your storage class. You can see, all the disks that are available for you. Now, the persistent volumes, those are the actual volumes themselves. So that means I'm going on that, that rack at Micro Center, and I'm grabbing a 50 gig hard drive. I don't even know if they make them that small anymore, but that's okay. So I'm grabbing that 50 gig hard drive, and then now I have it. That's my persistent volume. That's my persistent storage. Once you have your persistent storage in place, and I'm so sorry, everybody, I'm winging this here because I thought I was going to be showing this.
Let me ask you a question, Michael,
So,
while you're jumping that.
yeah.
You said I can specify my specific storage. Can I do my storage types, GP2, GP3 with the native in the same thing? Is that different? Do I have all the storage options that I do in a normal like EC2 instance, right?
Absolutely.
Within a Kubernetes. So I have that opportunity.
Yes, yeah. So when you're in your EKS cluster, you have a bunch of different options, right? Like whatever options are available for that CSI driver in your cloud provider of choice, those are the options that you have. So again, in Azure, you're gonna have Azure storage accounts. In AWS, you can have EBS, and you can have multiple, like you said. So in your EKS cluster, you can have multiple different storage classes that are available. It's not just one.
All right,
Yeah.
cool. All right, keep going. Sorry, I didn't mean to interrupt, but I was just wanted to do that while you were touching on the specific storage classes.
Absolutely, yeah. And by the way, everybody, I will be sharing out the code. I'm gonna grab the link and I'm gonna share it in the chat and all that after this. That way, you can actually see the code, and it's gonna make more sense what I'm talking about here. So once you have that persistent volume, right? So you have the storage class where you can pull your hard drive from, and now you have the hard drive available. What happens now? Well, now you need to attach it, right? So you're going to need to attach it to a Kubernetes pod. And much like, you think about it like this, if you pop open a server, if you pop open a laptop or a desktop, right? You take that hard drive and you put it in your computer, right? That computer or that server or that, whatever, that laptop claimed that hard drive. And that's exactly what the persistent volume claim is doing. It's taking this volume and it's saying, okay, I want to claim this volume on this pod. Okay. Now, once you do that, that means that pod is now readily available to use that volume. Now, of course, there are a few different things that go into this, right? One of the biggest things is if your pod needs persistent storage, right? If it needs persistent data, that means that volume needs to be somewhere. Now, when you're in the cloud, it kind of makes things a little bit easier because it's kind of up there, right? But if you're, for example, on-prem, well, you have to think more about, backup disaster recovery options for those volumes. And the same thing with the cloud, because those volumes can get corrupt in one way, shape, or form, okay? So what I want to do really quick on my end is I'm going to go ahead and I'm going to share something out in the chat really quick. Let me go ahead. I'm gonna give this a
While
shot.
you're sharing that out, Michael, I got a question from the chat that I want to just throw in since we're talking about the storage. Can you use EFS and EBS, one or the other, for Kubernetes and for these different storage types?
Yep, you can use both. Yeah. So if we see EKS, CSI add-ons, right? You're going to see a few different options that are available. You can take a look at those right there. Right. So one of the things that I want to do really quick is I just want to showcase kind of what I'm talking about here, right? So if you have an EKS cluster right now, you can go ahead and you can run that command. And what that's going to do is that's going to pull back any storage classes that are available. Now, of course, again, it's not on by default. So if you want it, you'll have to ensure that that add-on is there. Next, what you can do is, and this might look weird in the chat, apologies, but I want to send it anyways. That is how you can create your persistent volume. So you have your persistent volume, you give it a name, you specify, GP2 for the storage class name, and then the type of access modes and stuff like that. Now, here's where things get interesting. Let's say you're on-prem, right? And you got your rack of hard drives here in front of you. You pick and choose and you pick and you pick and you pick, and eventually it's going to run out, right? So that server or that SAN or that NAS, whatever you like to call it, eventually runs out of storage until you put more in. So that's why you would want to specify your persistent volume, okay? In the cloud, theoretically, you're not running out of storage. So typically what you'll see as a best practice in the cloud to kind of make things a little bit easier for you is you're going to use a persistent volume claim, which I am going to send out right here in the chat. And again, I'm going to send the GitHub link for all this stuff. So you would use that persistent volume claim. You would create a persistent volume claim, and then you would attach it to your pod. Now, notice how in that scenario, I did not say you had to create your persistent volume as well. That's because when you create a persistent volume claim and you attach it to that pod, that volume is now created. Now, you don't want to really do that on-prem all that much because, again, at some point you will run out of storage. However, in the cloud, you can keep pulling persistent volume claims as much as you want because theoretically you're not running out of storage there. All right. So that is essentially the gist when it comes to your storage classes, when it comes to persistent volumes, and then when it comes to persistent volume claims. Now, when we're thinking about storage again as a whole, I'm also thinking about databases. So what can we kind of do with databases? Well, one of the cool things that I like to do is you can actually take, let's say, a MySQL container and you can connect it to MySQL database running in RDS. And it's actually pretty straightforward. So I'm going to go ahead and I'm going to pop this command in here. All right. Now, as you can see with this command, it's a simple Docker run command. I'm specifying my MySQL container name, the port, except doing something a little bit different here. I'm specifying some environment variables, the MySQL root user, the MySQL root password, the MySQL database, and the host. Now, notice that host link. It's AWS Fest 0101, and then a bunch of characters, .rds.amazonaws.com. Now, if I run that, I'm able to then connect to my database that's running in RDS. Now, why is this cool? Well, you probably maybe have heard this in one way, shape, or form that databases or containers are not ready for databases because of the ephemeral nature. However, here's the thing. Let's say you're creating a pod, a Kubernetes pod, and you have a MySQL container, right? Or actually, I'm sorry, you're creating a Kubernetes deployment, which is the higher level controller for the pod. And then you're using the MySQL container image, much like how we're doing in the chat here with this Docker run command. You can specify the environment variables that the pod is constantly connecting to your RDS database, which means your application stack, right? How you're deploying everything, all of your workloads into Kubernetes is with pods and containers, but you're using outside resources. So you're using an actual database versus a volume. However, you can use volumes as well in databases. The biggest thing, of course, with that, and I'll go ahead and I'll pop in this command. For example, if you don't want to use something like RDS, you can very much use a volume that acts as a disk for your database. The only caveat.
That's how it's all coming together. I was like, well, what's the deal with MySQL? But here now we're specifying the volume for, okay.
Exactly. Yes. Yeah. So now this is the other method if you want to use a volume instead of, pointing to RDS or any database service. You can point to any database, and it doesn't even have to be in the cloud. It could be any database, as long as you have the host and the passwords and the usernames and stuff. But if you don't want to go down that route, you can very much use volumes as well. Except that's a big if you lose that volume, you're up the creek without a paddle. So you want to make sure that you're backing that up. You want to make sure that you're storing that in a certain way. You want to make sure maybe even that volume is an EBS volume, so you can do your backups and your snapshots and all that stuff in AWS.
Nice. Michael, I'm going to jump in. I got one question for you, and then we actually ran a poll, and then we're going to bring my co-host back on for his remarks. So, Michael, one of the other questions that came into the chat is we're talking about EBS. We're talking about a volume for persistent. What about S3? Can you use S3 for Kubernetes?
I think you can. Hold on. Use S3 or EKS. Yes, it looks like you can. Yeah. Looks like you can use volumes. I haven't personally done that with S3. I typically use EBS, but yes, it looks like you can.
Nice, nice. All right, so let me talk to you about the poll that we ran, why this was happening. So the poll that you put together is, have you implemented Kubernetes in AWS? We have a number of votes. Yes, at 21.88%, and it'll be 22 by the time. Oh, I'm sorry, it's going down. No, it's going up, 23, 25. Wow, I like how I start talking about the poll and people jump into it. So let's just say yes is at 30 already, just by this. Experimenting at 24%, and 47% not yet, which is key because a lot of folks might not have been implemented it just yet, and they're going to be moving to the experimenting stage. Now, before I bring Richard back on, everybody hit those emojis, give Michael some love onto his things, give him high five, thumbs up. I want to see some things. It's okay that we weren't able to show you a demo. He's going to provide a link to GitHub where all the information is going to be in the code that he was running. He dropped it in there, and I thought he explained it really well in a limited amount of time he had and without being able to share his screen.
Yeah, so that code is up there. I posted the repo, and then I also posted the how-to, and it's just a little directions on like the steps that I took. And you're going to see all that code there. So everything that I just spoke about, everything that I put in the chat, you will be able to run directly from that repo. Of course, as long as you have an EKS cluster and an RDS instance for the database.
Nice. All right. So let's bring on and stick around, Michael. We're going to bring Richard on, who's going to give us his insights and remarks on our first two guests. And then what we're going to do is some magic, swag, raffle, and then get rolling. Richard, please join me back to the stage again.
Hey.
Yeah, we can see you now. Are you part of the ops group?
I'm just completing Michael's hat there.
Oh, nice. All right, so Richard, what do you think so far of not only talking about the deep dive of Kubernetes and the different storage types, but also Amazon S3 Storage Lens presented by Stephanie?
Yeah, I mean, I think definitely Storage Lens is a step in the right direction. I think there's a lot more to go in that space, and I'm seeing this, and obviously our whole event for today is kind of a response to, like I said, some of the potential backlash that AWS had at reInvent last year. There was a lot of commotion in that sort of cost optimization space, and also a lot of the kind of the write-ups and so on have been around sort of cost optimization due to the global climate and various other things that are happening in the financial industry and all the other types of issues that we're experiencing globally. So there was going to be a tightening of belts for this year, and I think this area of kind of storage and how you kind of optimize your storage in cloud is definitely very important. I also asked a few of the folks in the chat, and the responses were definitely it's an area for them to be focusing on for this year. So this absolutely makes sense, and I think the more of that we get, I think for this year, and we more be able to help enterprises and customers, the better. One thing that actually did come up as a question was, can a lot of this stuff be automated? So a lot of people are obviously automating this through scripts and automation tools like Terraform or whatever. So would like to see a lot more of this kind of thing also being automated, not just in the UI, but also kind of part of a kind of a scripted API type of approach as well, so people can actually put that into scripts. Michael's, I think, demo is really, or his kind of talk around the demo was fantastic. I think there is a lot more of that scope. One question I had for you, Michael, around that was how much of this is actually kind of common knowledge? You're kind of obviously an expert in that space, and very much appreciate the insights. And again, I'm seeing lots of good feedback on the chat on kind of what you're talking about. But how much of this is kind of common knowledge to people, and is it kind of out there, so to speak?
Yeah, so I think if you're in the Kubernetes space, the idea of container storage interfaces or CSIs is very much a thing, because regardless of if you're running on-prem or if you're running in the cloud, you're going to need storage and volumes at at some point. Whether you have stateful or stateless applications, you're going to have something that requires persistent data. So I would say that part is common knowledge, but I think the part that isn't common knowledge is what plugins you use with which cloud provider and how you kind of get them up and running. Because again, thinking about AKS versus AKS out of the box, those storage classes are there for you. So you just kind of create a persistent volume and a persistent volume claim, and boom, you're good to go, and you have no idea how it worked. Let's say you're an engineer that then moves to EKS, and you're like, okay, I'm going to create it the same way. It's not going to work. So you might have to scratch your head and be like, oh, okay, well, what happened? And then you go in and you run kubectl get sc, and you're like, oh, there are no storage classes. Why? Because that's also something that you have to enable when you create your cluster. So then you might have to roll back, destroy your cluster, recreate. So I think it's more less around Kubernetes knowledge, more around how the managed Kubernetes services work in each cloud.
Right. Yeah. Because obviously CSI is is something dependent on what kind of vendor and technology you're using. So not just obviously the public cloud sort of solutions around storage, but if you're using NetApp or something else, they all produce kind of their own CSI, so you can actually access their system. So I think that is quite crucial. I did ask a question earlier in the chat to just kind of again maybe understand from people what kind of CSI they are using and implementing at the moment. That would be interesting to know. One other question around that sort of stateless application. Obviously, Kubernetes was started off as an idea of kind of being sort of having stateless applications. We've kind of maybe the industry's kind of backtracked a little bit, and we kind of have now we realize that we actually need stateful applications as well. Where do you think that sort of mix is at the moment? What do you think that kind of percentage is at the moment? What's your kind of opinion from the customers that you advise?
Mm-hmm. Yeah, so I would say you definitely see more stateless. There's still I still hear comments that Kubernetes isn't ready for stateful. That's 100% incorrect. You can run your workloads just as good on Kubernetes with stateful sets, as you can with anything else. Because remember, stateful is simply keeping your unique ID, right? It doesn't have anything to do with persistent storage. It doesn't have anything to do with volumes. It's literally just keeping a unique ID of your pod, because that unique ID is used and needed later on by other pieces of your application stack. And that's solved very easily with stateful sets. Now, again, I still see a lot of people kind of saying that aren't super in depth with Kubernetes. A lot of folks are saying no, it's not ready for stateful applications, but it very much is. There's a bunch of different ways to do it with stateful sets. Stateful sets are literally the same thing as deploying pods with deployments. The biggest difference is, number one, your unique ID gets held. So if your pod goes down, it comes up with the same unique ID. And then the second part is, you're just using a different API. But that's about it. Everything else looks the same. If I put a deployment manifest in front of you and a stateful set manifest in front of you, and I blanked out the API and the kind, you wouldn't know the difference.
Right. Excellent. Yeah.
Well, let me jump in and ask a quick question. Richard was talking about, obviously this year is huge for cost optimization and watching and tightening your belts. We did a poll just a few minutes ago, and somewhere around 40-some% haven't even implemented Kubernetes. How does one invest in this? Is there a cost optimization effort to work towards Kubernetes? Am I going to actually get some cost utilizing it or implementing my application on it, but I have to invest upfront time and money?
Good question. So I think with any tech stack, right, whether you got a bunch of VMware boxes or ESXi boxes rather, or you got a bunch of bare metal boxes, or you got a bunch of VMs in the cloud, or you got Kubernetes, you're spending money either way, right? Oftentimes you're spending more money than you probably have to, hence why cost and resource optimization is such a huge thing right now, and why it continues to become a thing. So in terms of cost savings and cost spend, I wouldn't think about Kubernetes so much of am I saving a ton of money here? It's more about saving a ton of engineering power, so to speak, because there are a lot of things that are abstracted away from you. One of the things that's huge, for example, is the ability of self-healing pods and self-healing Kubernetes resources, and then also your auto scaling. Like that right there takes away engineers having to wake up at 2 a.m. That right there takes having to architect the idea of having virtual machines that are cutting over to another data center that on-prem with throughout your VMware environment and stuff like that. So it's less about cost optimization and more about not only resource optimization but people optimization, in my opinion.
Nice.